So today we're talking about algebra with two-step equations. So far we have learned how to solve one-step algebra equations with addition, subtraction, multiplication, and division. So you should already know then how to solve this problem. 4x equals 36. Now remember, Pedro, when you have a number squished next to the variable, what operation is that?
Division.
What are you seeing here? Is that division or multiplication?
Division.
That's multiplication, right. So then to undo it, you do the same thing to both sides, and you divide by 4. Again, there's a reason why we picked that, because 4 on the top and 4 on the bottom can cancel out. We have x equals 36 divided by 4, which is? 9. Thank you. Good. So you only had to do one step to get x by itself. You just had to divide through both sides. Today, we're going to learn how to solve two-step algebra problems. Now look at this example using multiplication, right here, and subtraction. Two operations are being done now. Don't let it scare you. Just follow two simple steps to solve it. And those of you who have been doing this in your head, you're going to have to come to terms right now. Step number 1, undo the addition or the subtraction first. I call these loose numbers. They're not connected to the variable. We're going to get rid of these first. So be sure to do the same thing to each side of the equation. It's really the same thing that we did the other day talking about one-step problems. Look and see what operation do you have going on right now. What is this right here? What's being done with the 9 though? Subtraction. The opposite of subtraction is addition. It's right there. So here you have a minus 9, so you're going to put in a plus 9 to both sides. Be sure to do the same thing to both sides. And that is going to allow us to cancel this out. Those 9s there are gone. Negative 9 and a plus 9 becomes 0. So we have 3x equals 45, because 36 plus 9 was 45. Now we're not done yet, but hopefully this is looking a little bit more familiar to you. Now we're back to a one-step problem. Step number 2, undo the multiplication or division last. So again, be sure to do the same thing to each side of the equation. We have 3x equals 45. We're dividing through both sides with the number that's attached to the x, which would be a 3. So the answer then is x equals 15. All right, so we had two steps. First, we had to get rid of the loose number by doing the opposite. Then, we're continuing the same problem, we had to get rid of the multiplication by doing the opposite. That was 2 steps. Right, let's move on now. Let's try some of these practice problems here. Remember those 2 steps that we just talked about. Get rid of the loose number first, then work with the variable. I'm seeing a few confused faces, so let's do this one together. 2x plus 1 equals 11. The step said to work with this one first. This is addition, right? So do the opposite. Subtract 1 from each side. I can't even really work with the x yet. I can't get to my x until I get rid of this loose number here. So subtract 1 from each side. These will cancel out. But this time I have 2x left, right? Not just an x anymore. 2x equals 11 minus 1, 10. That was one step. Now we're on to our second step. This is multiplication. Let's do the opposite and divide both sides by 2. This is like unraveling a giant sweater, right? Just keep unraveling. 10 divided by 2 is 5. The more steps the more complicated your problem is, the more steps you have to unravel. All right, try this one. 4y minus 1 equals 15. But as a group, let's decide where we're starting first. Which is what? Negative 1 or minus 1. Start here. This loose number that's not attached to the y, let's get rid of that first because that's the easiest one to get rid of, quite honestly. The one next to the y here, the 4, is a little bit harder to get rid of. So just get rid of the negative 1 first by doing the opposite. I am hoping that you added 1 to each side.
Yes.
Excellent. The reason you did that is because it turns out that negative 1 and plus 1 just becomes a 0. So I've still got 4y on one side, but on the right I've got 15 plus 1 equals 16. So let's rewrite that to make it a little bit neater. 4y equals 16. Now that should resemble the one-step problems that we've been working on. That's multiplication. 4 and the y stuck to each other like that. So how do we undo this? Divide. What you do to one side, you must do to the other. So Richard, did you divide both sides by 4 or 16?
4.
Okay. Both sides divided by 4. This simplifies here. 4 over 4 gets canceled. I'm still left with y on the left, but I have 16 divided by 4 on the right. 4, right. Any questions on that one?
So the 4y 0 equals 16. It's not necessarily right to write it.
I don't have to write the 0, no,
Yeah.
not at all. That's okay in your head just to cancel those two out if you want to. Okay, so we have n divided by 2 this time, plus 5 equals 15. Okay, before you start to say, I can't do that, there's a fraction there, let's just go ahead and do one step. What's the easiest step to work with? The loose number, thank you, good. So what is the loose number here? Yeah, that probably doesn't really belong there. It's kind of, that n is stuck to the 2, but then 5 sort of just hanging out there. Let's get rid of it. You've got a plus 5, so do a minus 5 to each side. That lets these cancel out. And I have n over 2 remaining on the left side equals 15 minus 5, which is 10. Good. Okay, so we got one step done. Now we're down to our second or our last step. It shouldn't look too complicated here. This is division. How do we undo division? Good. Multiply by a 2. Very nice. The reason we picked that is because 2 on the top and 2 on the bottom, or diagonal like that, can cancel. I'm still going to have n on the left side. 10 times 2 is 20. Good. All right, last one of these. Again, it's important to know where to start. Do you even want to start with this k over 7? Or do you want to start with the negative 14?
Negative.
That's right. Get rid of that negative 14 first. The opposite of a subtraction is an addition. So add 14 to each side. What you do to one side, you must do to the other. Now these will cancel out, but I've still got k divided by 7 on the left. On the right, I've got 16 plus 14. Is that 30? Now k divided by 7 equals 30. What's my next step?
Multiplication.
That's right, because this is division. So do the inverse, or the opposite, and you're going to multiply each side by 7. And I picked the 7 so I could just cancel. Easy, right? I'm left with k on the left And 30 times 7 on the right. That's right, 210. K equals 210. Okay, unfortunately, there is an exception to the rule. All right, don't panic when you see a problem like this.
Oh my God.
Okay, this is the exception to the rule, and they're going to start to look really complicated. I just need to explain this to you. Remember up above when I told you to start with this loose number? Here you can't. You can't when there's a fraction bar that's dividing the whole side there. Think of this top as a family. Everything on top of this fraction bar here is a family unit that cannot be separated. You must work with this bottom number first, the 5 here. And here's what I wrote for you. In this case, you can't undo the addition first. You may not separate the group in the numerator, which is this one, until you get rid of the fraction. In this case, undo the 5 first by multiplying both sides of the equation by 5. And here's what I did.
And you always use the bottom number?
You do. You always use this number under the fraction bar for the same methodical reason that we talked about. It's going to let you just cancel. Because if I put a 5 on the top on both sides, that lets me cancel out these, right? And then I'm left with m plus 3 equals 3 times 5, which is 15. At this point, suddenly that problem looks much easier, doesn't it? Once you get rid of that fraction, m plus 3 equals 15, now you're back to one step. Do the opposite. Subtract 3 from each side. M equals 12. So I don't think that last step was the complicated part. It was looking at this one and realizing, aha, that's the exception. That's the exception because you've got a variable plus a number and the whole thing is being divided by another number.
The pi is still the lowest number because it stands by itself.
What's that?
Remember, pi is still the lowest number because it stands by itself.
That's a good point. So the number 5 kind of is still the loose number. Since you can't separate this family unit here, you have to work with this one down here, right? Anytime when you're doing algebra, if you have a fraction like this, you can't work with the top number until you get rid of the fraction. Fractions are basically the exception to the rule.
So let's say it's if denominator, they have two numbers, or three numbers, 5, 5, or 5, 5, 5. So
Okay.
the denominator first.
I had to see what you mean. I think you'd have to show me that.
So over here, n plus 3, right? Divide by 5. So you say it's do number 5 first.
That's right.
It's a denominator?
Yes, because it's the denominator. Always work with the denominator or the bottom of the fraction first. Always. Right. So let's do a couple of examples. I know that was a complicated exception, but that's actually a very common exception, unfortunately. You will see a lot of these like this. We'll do the first one together. M plus 2 over 4. I do want you to realize that this is not the same thing as what we did on the first page. I am not showing you this problem. Can you recognize the difference here? On page 1, this is what I was showing you. M divided by 4 plus 2 equals 6. And we said, hey, let's work with our 2 first. Look how they're different, though. They're not the same. This time I've got m plus 2 as a unit. The whole thing is over 4. That's your exception, when the whole thing is over 4. So you can't work with this 2 first. You're going to have to get rid of your fraction here, which is division. So how do you get rid of a division problem? Use multiplication. So what number do I pick then?
4.
That's right, pick the 4. We did that for a reason, so I can cancel the top 4 and the bottom 4. You're still left here with m plus 2 on the top. Equals 6 times 4? 24. Right. Now does it look better?
Yeah.
Now you can probably do that last step. You have addition of 2, so do the opposite. Subtract 2 to both sides. Right. M equals 22. Good. So I want you to stew on this for a few minutes as you try and do these last 3, okay? All right. Y minus 1 over 7 equals 2. You cannot work with this -1 like I told you at the beginning of the notes that you could do, because these numbers here, y minus 1, is the numerator, and you cannot separate that until you get rid of the denominator. So multiply then both sides by some number. What number do I pick?
7.
That's right, and you're going to pick 7. I know, Richard, you like to say this because you're going to cancel, right? Top 7, bottom 7 cancel out. I'm still left with y minus 1 equals 2 times 7, 14. Right, now this should look a little bit more familiar. This is a subtraction here. Undo it with the opposite. Add 1 to each side. These can cancel. I have y equals 14 plus 1. That's 15. Questions on that one?
I got 15.
Oh, good job. Excellent. That's a 2-step problem. Very nice if you're getting these already. Okay, z plus 4 divided by 5 equals -1. So notice that -1 there, and your answer should account for that. Don't lose it at the beginning. This is division, so let's undo it with multiplication. What number do I multiply both sides by?
5.
5, exactly. Because a 5 on the top simplifies or cancels with a 5 on the bottom. But I still have my 5 over here. And that's the whole point to doing this, right? Now I have z plus 4 equals -1 times 5. Don't lose your negative. There's only one of them here, so you have to keep it. -5. So this is back to a 1-step problem. You have addition, do the opposite, and subtract. These are going to cancel out. That's going to be 0. I have z equals, what is a -5 and a -4 added together? Not a positive. We're adding them.
-9.
Yeah, we're adding.
-9.
If you used a number line, yeah, you would come up to a -9. There we go. -9. You got it? Very nice, Pedro. All right. This is a little bit tricky, as Wodenesh said. She didn't like seeing this negative down here. So this
I
is,
did it, but
you did it good.
Yeah.
This is division. Do the opposite and multiply each side by some number. Should I use 3 or -3? That's right. We want to keep the negative with it. If I use a 3, I'm still going to have a negative down here. So bring the negative with it. -3. It's being multiplied on both sides here. That lets me cancel a -3 on the top, a -3 on the bottom. I have x plus 10, that's what's remaining, equals 10 times -3. Keep your negative, and that becomes -30. All right, now we're down to a 1-step problem. This is addition, do the opposite, and subtract 10 from each side. -40, that's right. -30 plus a -10 is a -40. Anybody get all 4 of those right? Yeah, a couple of you did. Very nice. Good.
I got a little bit confusing about 30, -30, and -.
Yeah, this was a little bit confusing going back to the negatives then and how you have to do these. If you had a number line and you added a -30 with a -10, you would get a -40.
So how do we know it? Minus.
This side is always going to be adding something to it. Like this, you were adding -5 and a -4. And here you're adding a -2.
it's confusing.
It is a little bit confusing, and I think practice is about the only thing that you can do to really get a good feel for how these work on the right here.
But usually we're learning like negative comes positive, and now.
Well, when you're multiplying, 2 negatives make a positive, but when you're adding 2 negatives, right, it makes a negative.
So it's opposite